Okay, so the next question that we have is a question over here, and I did try to solve the problem, but I think I did make a mistake. Let's see basically how let me try again to solve the problem and see where the problem was. So let me start from the very beginning. So basically the question is, and it's a good question really. Okay, so the question is basically in what ratio does the x-axis divide the segment joining the following points? So the points are -3, 4, which is this point over here, and 2, 5, which is this point over here. And if you draw basically the line segment, of course the line is going through the x-axis, and it will have some intercept on the x-axis. I've called the intercept C, for example. Now, what you can do is that you can find the point of intersection of the Okay, so what you can do is that you can find basically the equation of this line, and then you can find, and then the equation of the x-axis you already know, and then based on those two pieces of information you can find the point of intersection of this line with the x-axis. And so that point of intersection would be C, and then you can use C in that formula, in the section formula, to find the ratio in which the x-axis is dividing the line segment AB. That's possible, but well, of course it's not really necessary to go through all of those steps, meaning that what you can do, which is actually the solution that I just saw over here, is well much better than my solution. I mean, it's much shorter, sweeter. So what you know over here is the y coordinate of this point is 0. The y coordinate of the point C is equal to 0. Now let's say that, for example, well, of course, over there they have used k and k to 1, which I don't really understand. I mean, since I don't understand, I cannot use it in my solution. I could use that sort of thing in a different way, but not that way in my solution. So basically what I can say is that the point C divides the line segment AB internally in the ratio m to n, for example. And if I assume that if I assume that's the case, then that means that AC to BC is equal to m to n. Okay. Now, using the section formula, what we can write is that basically the coordinates of the point C is equal to basically mx2 plus nx1 over m plus n, and then you can write my2 plus ny1 over n plus n over n plus n. And so basically I know that the y coordinate of this point C is 0. So that means that I can write my2 over n plus n, and the numerator has ny1. This is equal to 0. If this is equal to 0, that means that the numerator is 0. So this means that my2 plus ny1 is equal to 0. And so what that means is that y2 over here, if I take this as point, I of course, based on what I've written, I should take this as point 2, take this as point 1. So then my2 is negative 5, and y2 is negative 5 plus n times y1, which is equal to 4, is equal to 0. So negative 5m plus 4n is equal to 0. And so I can divide this equation by 4n, negative 5m over 4n plus 1 is equal to 0. And so negative 5 to 4 m to n is equal to negative 1. Simplify these two. And then m to n is equal to 1 over 5 to 4, which is 4 to 5. That means that m is equal to 4 and n is equal to 5. Much better than my solution, than the solution that I used before. And well, I got some two numbers like 26 and 19, which of course I don't really know how that happened, but that's basically this question. We have a couple more questions over here. Let's do these as well. So example number 6 is 3 vertices of a parallelogram ABCD are given below. So these are, so A is equal to negative 2 comma 2, and B is equal to negative 4 comma negative 2, and C is equal to 3 comma negative 1. These are the 3 vertices of a parallelogram. Find the you want to find the coordinates of D. What is the coordinates of D? So if I plot these points over here, I get negative 2 comma 2. Negative 2 comma 2 is this point over here. So it's this point over here, it's point A. And then point B is negative 4 comma negative 2, which is this point over here. That is B. C is 3 comma negative 1, which is this point over here. This is point C. So if I connected these points together, I will get something like this. And point D must be somewhere over here, because in a parallelogram the sides must be parallel, of course, and that would be most probably something like a rectangle. Now, in order to find out okay, so let me see how we can solve this problem. Okay, so now basically the way that I thought about this, and well, I mean, whatever sort of parallelogram you might have, suppose that you have this parallelogram over here, and if this is a parallelogram, the diagonals of a parallelogram will bisect each other at the exact same point, meaning that not at the exact same point, but the intersection of the diagonals of a parallelogram are the midpoints of both the diagonals, meaning that if I call this ABCD, and if I assume that ABCD is a parallelogram, then if I call this point O, then basically O is the point of intersection of the two diagonals of the parallelogram, and basically AO is equal to OC, and DO is equal to OB. And this happens whatever sort of angle you might have over here, or here, as long as it's a parallelogram, this is going to happen. Meaning that, suppose that you have your parallelogram, for example, it's this parallelogram over here. Suppose that this is a parallelogram. Now this, if I draw the diagonals over here, of course the length of the two diagonals are not going to be the same. But this point, again, if I call this A, B, C, D, and O, again AO is equal to DO, and CO is equal to BO. That's going to happen all the time as long as you have a parallelogram. And you know that a rectangle is a parallelogram, basically. A square is a parallelogram. Even a rhombus is a parallelogram, meaning that if all the sides are, let's say that you have all of these sides, there are basically two types of such shapes, geometric shapes. I need to do a simple experiment. Suppose that now if I have all of these equal, if I have all of these distances equal, then I will get a square, basically. I will get a square. Okay, so that's basically what I just said. Now if I have this geometric shape over here, and that I have basically this distance over here, this distance over here, and the same distances along these two lines, what I will get is basically now you see that these two lines are parallel, and these two lines are also parallel, and this is either called a rhombus or this is, I suppose, is called a rhombus. And in this case as well, basically the diagonals are the bisectors of one another. So that's basically what happens in a parallelogram. Now this is one thing. Now you need to keep this in your mind. And I want to explain something else as well, and then we will go back to what we just said and then solve this problem. So now you can see that I have this I have these 3 points over here, and these are the vertices of a parallelogram. So what I can do is that I can find the equation of this line, because I have these 2 points on the line. I can find the equation of this line because I have 2 points on the line. I can find the equation of a line parallel to this line, and 1 point on this line, meaning that the slope of AC is basically, we already know the slope of AC, and we know 1 point over here. So if there is a line that goes through the point B, and the slope of that line is the slope of AC, then we can find the equation line over here, which would be some line like this, which would be some line, for example, like this. Suppose that these two lines now are, suppose that these two lines are parallel, and the line goes through this point. And also I can find the equation of the line that goes through the point C and is parallel to AB, meaning that the line is parallel to this line and goes through the point C. So it goes through the point C, and the slope of the line is the slope of AB. Now once you find the equation of these two lines, you can form a system of equations using the equation of these two lines, and then find the point of intersection of the two lines, which would be this point over here, which you can call D. That way you can solve this problem. But it would require you to do a whole lot of calculation, find two equations first, find two slopes, and so on and so forth. So it's not, I mean, using that property of the parallelograms in which we just talked about, in which basically where the diagonals are the bisectors of one another, that's easier in this case to solve this problem. And I still don't have a good strategy of using that, but we will see together how that works out. So now you can say that let the point D with, for example, coordinates h comma k, let D have basically let basically point D be the point where you are looking for. Now, since the diagonals of the parallelogram must bisect each other, since the diagonals of the parallelogram bisect each other, the midpoint of AC must be the same as the midpoint of BD, meaning that the midpoint of the, if I assume that, for example, point D is somewhere over here, for example, let me draw some line over here just arbitrarily. If I assume that D is some point over here, and if these are the diagonals of the two diagonals of the parallelogram, then I can say that the midpoint of AC, the midpoint of AD, the midpoint of AD must be the same as the midpoint of BC. Must be the same point as the midpoint of AD and BC over here. So now using the section formula, you can calculate the midpoint of AD. So the midpoint of AD, basically it would be, if I call this point, for example, I don't know, if I call it, for example, point O, having the coordinates, for now we just don't need any coordinates for that, but then basically the coordinates of the point O with respect to this line AD would be the x coordinate. What would be the formula is basically this. So AO would be basically m times x2 plus n times x1 over m plus n. Or since we are talking about the midpoint, you can simply write it as x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So what I can write over here then is basically I can write, so I have points A and D. So the coordinates of the point A are negative 2 comma 2, and the coordinates of the point D are h comma k. So you don't really need to bother about the ratio anymore, because the ratio is 1 to 1. So then I can write negative 2 plus h divided by 2 and comma basically the y's would be 2 plus k divided by 2. That would be point O. Now if you want to calculate the midpoint of basically the BC, which would be the same point O, that would be the same point O, and then you would calculate it as basically the point BC. So the point B is basically negative 4 comma negative 2, and the point C would be 3 comma negative 1. So then you would have negative 4 plus 3 divided by 2 and negative 2 plus negative 1 divided by 2, which is equal to negative 4 plus 3 is equal to negative 1, so that's negative 1 by 2. Negative 1 by 2 comma negative 3 by 2. Negative 1 plus negative 2 plus negative 1 is a negative 3 by 2. So that means that the coordinates of the point O are negative 1 by 2 and negative 3 by 2. And over here we said that the coordinates of the point O are basically these two. So that means that negative 2 plus h divided by 2 comma 2 plus k divided by 2 is equal to negative 1 by 2 comma negative 3 by 2. And so what that means is that negative 2 plus h divided by 2 is equal to negative 1 by 2, and 2 plus k divided by 2 is equal to negative 3 by 2. We can simplify these two, and then over here h is equal to negative 1 plus 2. Negative 1 plus 2 is equal to 2 minus 1, which is equal to 1. H is equal to 1. And over here you can simplify these two. K is equal to negative 3 minus 2, which is equal to negative 5. So the coordinates of the point O, would be 1 comma negative 5, and 1 comma negative 5 would be But the solution that I see over here doesn't really make any sense. Well, I think that the solution that they have over here is somehow wrong. And I have gotten this solution here, which is not O, but D. The coordinates of the point D are 1, negative 5, which is 1, negative 5, and it does make sense. I mean, this seems to be a parallelogram. Now, I just need to go to basically find some, let me use Geogebra. So if you go for the geometry part of Geogebra, you can go over here, you can show the axes and show the grid, major guidelines and major and minor guidelines. So then you can put a point over here. Let me take a look at the points that I had where A is equal to negative 2, 2. So I put a point over here, negative 2, 2. The other point that I have over here is negative 4, negative 2, which is this point over here. Another point is C, which is 3, negative 1, which is this point over here. Now if I connect these line segments together, and let me actually put the point that I have found as 1, negative 5. 1, negative 5, I put it over here. And if I put this line segment over to these, now if these two angles, I suppose that if you go over here and basically measure this angle here, it's 85.6 degrees. This angle over here is 85.6 degrees. So these two angles are actually the same. Now this angle over here is 94.4 degrees, and this angle over here is 94.4 degrees. This is exactly a parallelogram. So I think somehow the solution over there is, I don't know, there is something wrong with it really. Or I can even come back to the solution here, and they have found, basically, as you can see, these are the exact points that we have over there, negative 2, 2. I need to sometime close some of these tabs because I really don't know where I am. But this is negative 2, 2. This point over here is 5, 3 is 5. I don't have any 5, 3 over there. Okay, so let's say the 5, 3 is the point that they have found. Negative 4, negative 2. Negative 4, negative 2, this point over here. The other point is 3, negative 1. 3, negative 1 is this point over here. And the point that they have found is 5, 3. is 5, 3. Now if I put a point over here, 5, 3 over here, and I don't really know how to, and they have connected this way, negative 2, 2 to 5, 3, negative 2, 2 to 5, 3, so that way. So if I delete these, and I will delete my own point, this is also possible. Meaning that if I find a line segment, and a line segment over here, and a line segment over here, and a line segment over here, this is also actually a parallelogram. And I can actually go over here and measure these angles, which is 124.7. This is 120. I can move this over here. 124.7. And this angle over here is 35.3, and this angle over here is 55.3. I'm sorry, 53.3. 55.3. This is also a parallelogram, but so their solution is also right. Now it just depends on the midpoint of which points you find, and then you will either find a parallelogram in this orientation or in the other orientation. But none of the solutions is wrong. Both are right. It's just that they are different, and you get basically two cases of a parallelogram. Okay, so let's see about the other problem, the next problem, and see if that's something it's about the centroid of a triangle, but we don't need to really do this anymore because we are kind of getting into geometry, which is not what we wanted to do. So I think we have done what we really wanted to do. And so what we can do is basically get back to where we were, which basically the section formula that we wanted to do in 3D geometry. So I'll end this video here, and then in the next video we will talk about the section formula in 3D geometry. I'll see you in the next video. Thank you.